So now in this video we're going to use the 741 op amp. We're going to wire it up as a unity gain voltage follower, and basically we're going to set the output of the op amp to the same voltage that we have this trim pot. So we have this 741 op amp up here that we already have wired to split the rail here. So our 0 volt reference point here is now ground. That's our 0 volt reference point. That's 9 volts more positive, and then the blue rail is 9 volts more negative. Red rail 9 volts more positive. And so the trim pot, in reference to this point, we can either go all the way up to 9 volts or all the way down to 0 volts. And we're going to basically make this circuit, but the voltage divider is going to be set by this trim pot, and so it can go anywhere from positive 9 volts now to negative 9 volts. Halfway is 0 volts, of course. And so all we have to do, same as this one up here, we take the output, third pin down on the right, pin number 6, and wire it directly to the inverting input. So that's pin number 2, second pin down on the left. And we have that there. And this jumper, I'm pretty sure it was just like one of these jumpers, and they're all different lengths though, they're different colors, and I just kind of bent it so it'll go over the integrated circuit. So in any case, we have that. Now we're just going to wire the trim pot directly to this, and the point is we're getting a variable voltage that we're setting with this, so we're going to get the same voltage. We'll see that later, but this is a 10 kilo ohm resistor, so at the halfway point there's 5,000 ohms towards the positive rail, 5,000 towards the negative rail. Very little current flows, and so the only thing limiting the current from the op amp will be the load, and also the op amp limits current. So we're going to look at that in an upcoming video. But in any case, we're going to have a red LED. We're going to light it up so that when the output is a high voltage, higher than about 1.5 volts, it's going to light up. So we're going to put the short lead, the cathode, to this jumper that goes to virtual ground. I'll zoom in on this for this one. And there we go. So short lead, the cathode's going to go to the ground. Long lead, the anode's going to go down one row, because we want this to light up when the output is more positive than our virtual ground right there. And then the green LED, we want the opposite. We want it to light up when the output's more negative, and so we're going to put the long lead, the anode, to virtual ground. Short lead, the cathode's going to go down one row, and to protect it, we're going to use a 1 kilo ohm resistor. So we'll have the voltage drop of the LEDs, but otherwise there's a 1 kilo ohm resistor setting the current based on the voltage. And so for each volt across the resistor, we'll have 1 milliamp of current. It doesn't rely on this trim pot at all. And I have a bench power supply that is off right now, but I need to move these jumpers over. The bench power supply has alligator clips at the end of the wires that you plug into it. So I just have these other alligator clips that I crimped onto jumper wires to be able to plug into the breadboard easier. And now we will turn on the power. You can see the trim pot's a little bit more towards the negative side of the power supply, and the green LED is on. And let's see, okay, this shot's not too bad. Now if I turn it more towards the negative rail, at some point it's going to stop getting brighter, but right about there it stops getting brighter, because the 741 op amps don't go all the way to the rails. So we'll look at that. But you can see the red LED, it's going to get a little more current that way. Red LED is just naturally not as bright. Plus this might be one of the LEDs, red LEDs, that aren't as bright, either because different manufacturers, or I may have damaged it over time. I'm reusing the red LEDs a lot. So we'll measure voltage. This is auto ranging. I don't have to move the probe only one spot for voltage. Only time we move the red probe is for high current. So right now we have less than, it's a little bit more positive, less than 1.5 volts. And you can see we got 1 volt there. And then we got 9 volts there. And then negative 9 volts for the most part to the negative rail. And so let's go back to our virtual ground. So I'm going to the output there, pin number 3, that little blue jumper we saw earlier. And so we got basically spot on 1 volt there. At the output here, we got the exact same voltage. So now let's go get the red LED on fairly brightly, and you'll see we got 6.84 volts there and 6.85 volts there. Pretty much spot on. That's about as high as we can go though, because as I said, the 741 op amp doesn't output, going back to our virtual ground, all the way to the rail. Okay, it's actually going to the rail on that one. So, or 8.9, no, that's the voltage for the trim pot, never mind. The trim pot does go to the rail, so 8.94, but that's 7.91. So 7.91 is the maximum we will output with this trim pot, or with the output of the 741 op amp in this case. So I can go anything below that, but not down to the negative rail. So let's go more negative again. Let's look at the voltage. So the virtual ground, the output of our virtual ground 741 op amp. So there we got negative 5.761. We should have the exact same right there. We're just so we got negative 6.073, so slightly off. Let's go a little bit lower. But there you can see, we got a programmable voltage. I'm not making a connection. There we go. 3.534 and then 3.6. So just slightly off, but it is really close. It's holding pretty steady. Now we're gonna go. Let's just go to the negative rail to begin with, and there we go up there. So negative 8.95. Now we'll see what the limit is. So the limit is negative 6.7 on the negative side, and so we gotta, to stay true, we can't go any more negative than what was it, 6.7 or so. So 6.9, we're still a little more negative. We gotta go a little bit lower. But in any case, this is just a demonstration circuit, so hopefully that makes sense. The way that we have this wired up that I showed you, we get the same voltage at the output. There's a few complications, but it's relatively close to the output we set with the trim pot. And we don't have to give any current out of the trim pot, just a very, very small trickle, insignificant amount really. And so it doesn't alter the voltage we're getting out of the trim pot really. The voltage that we set it to stays pretty true. And so it doesn't matter what the load is, as long as the 741 op amp can handle it and it doesn't exceed the range that it can output. So those are all topics to investigate further, and I'll cover them in future videos hopefully. But this is a simple demonstration circuit that I think demonstrates this nicely. So thanks for watching. I will see you in the next video.